So the factors which were affecting the speed or the rate of the reaction, the first one we were discussing, that is about the concentration, which also refers to amount of the particle in a unit space. The concentration refers to the meaning of a concentration. It refers to number of the particles in unit volume. It's same like concept of the density. High density means high concentration. Low density means low concentration. So if we have high concentration and we have low concentration, so the term high concentration means there are more particles in a unit space, and the term low concentration means there are few particles in a unit space. So high concentration will have more collisions and the low concentration have few collisions. When there are more collision, always remember the collision theory. According to collision theory, if there are more collisions, it means there will be a faster rate, greater rate. So high concentration, the particles have more collision, they will collide more often as compared to low concentration. And as they collide often, what it results? It results that they form a product. And the second thing what happened, because the high concentration, more particles are there, it will form more product as well as compared to low concentration. So if we sketch a graph, for amount of the product and the time, so low concentration, it will be less steeper and smaller amount of product will be formed. But high concentration, the graph will be much steeper and greater amount of product will form. So this is a graph for high concentration and the other one is a graph for low concentration. Why the amount of the product is different? Why high concentration giving more product than low concentration? Because high concentration is having more particles. If more particles of reactant, there will be more product. Low concentration is having few particles. So if few particles are there, there will be fewer product. And why the high concentration, the reaction is faster or it is much steeper than compared to low concentration? Because when the concentration is high, the particles are colliding often as compared to when it's a low concentration. Is it clear, the concept of concentration on the rate, the effect of concentration on the rate of the reaction, that how it affects the amount of the product as well as the rate of the reaction? The second factor which affect the rate is the temperature. So effect of temperature on the rate, like example, we have same concentration, say 7 particles here, and we have 7 particles here. So these 7 particles at 30 degrees centigrade for the reactant, these are 7 reactant particles at 30, and another one the same 7 reactant particles are there at 7 degrees centigrade. At which temperature the reactant particles are moving faster, at 30 or at 70? So the second one, B, because the temperature is higher, so reactant particles are moving faster. Here the reactant particles are moving slower. Which one have more collagen, at 30 or at 70? At which temperature there is more collagen? So at 70 there will be more collagens as compared to 30 degrees. So at which temperature the reaction will be fast, at 70 or at 30? So 70 the reaction will be faster, and at 30 the reaction will be slower. So when we increase the temperature, the rate of the reaction also increases. So when we sketch the graph, if we want to sketch a graph for the temperature, the amount of the product and the time, so at 30 the reaction will be slower as compared to 70. The reaction will be faster, but the final line, the amount of the product will be same. The final amount of the product is same. Why the final amount of product is same? Because we have same number of particles of the reactant. So this one is at 70, this one is at 30. So high concentration and low concentration. Why the amount of the product was different? Because there were different number of the particles. But when we increase the temperature, the number of the particles are the same, like same number of the reactant particles, but they are having more collagens at high temperature, which leads to a faster rate. Is it clear? That how the temperature affects the rate. So when you increase the temperature, the rate of the reaction will also increase. The third factor which can affect the rate is the surface area. So what is the effect of surface area on the rate or the speed of the reaction? So example, we have equal volume, like these all have the same volume, but different surface area. Which one is having a large surface area? A, B or C? The total surface area. Which is having the total large surface area? Area of the surface. A, B or C? When you look at this figure, which one appear to have the large surface area? The correct is C is having the large surface area compared to A and B. Why? Because you can see for A, only this part is exposed. For A, only these parts are exposed. But for B, inside parts are also exposed. And for C, there are many parts inside and outside, all are exposed. So when you crush a substance. When we crush a substance, it means we increase the surface area. So if we have a lump and same substance in a powdered form, equal volume but the same substance in a powdered form. So this is a lump, this is a powdered form or granules. Which one is having a large surface area? The total surface area when you calculate. Lump or powder? So powdered is having a large surface area. That's right, this will have a large area or large surface area. And this is having a small surface area. And we can also say this is large particle size and this is small particle size. Size of the particle is small but the total surface area is larger. Here size of the particle is big but the total surface area is smaller. So when we try to react, like example, when this substance A is reacting and substance B is reacting, which one you think will react faster? A or B? So B will react faster because more particles at the same time can react with the surrounding. So B will have more collisions or faster reaction and A will have slower reaction. So whenever you want to increase the rate of the reaction, what you should do, you should always use a powdered form. Like example, if I have sugar cubes and I have a fine sugar, like two things are there, one is sugar cube, a large sugar cube, another one is fine crushed sugar. Which one you think will dissolve faster? The fine sugar will dissolve faster because it's having a large surface area, so it will easily dissolve as compared to a sugar cubes. So what is the effect of surface area? If we increase the surface area or decrease the particle size, the rate of the reaction will increase. So if I sketch a graph here for the product and time, so we have two graphs, example A and B. Which graph is there for powder or large surface area, A or B? Which graph is there for a large surface area? The amount of the product will be same. So B is for large area. So B is actually the graph for a large surface area. And A is for small surface area. Or we can say B is for the powder and A is for the lumps. So increasing the surface area will also increase the rate or the speed at which the reaction progress. Then another factor which affect the rate of the reaction is known as the pressure, but that is only valid for gaseous reactant. So what is the effect of pressure on the rate? Pressure affects the gaseous reactions only. So example, we have two containers. One is large container, another one is small container. And both have the same amount of gas at same temperature. Temperature is also same. Which container there is a high pressure, A or B? The first one is A, the second one is B. Which container the pressure is high? So B, the pressure is high, and A, the pressure is low. So which will react faster, and which one the reaction will occur at a faster rate? Which one have more collagen? Because it's a small area, a small volume, and more particles, in like particles are closer, so they will have more collagens here, and here the particles will have few collagens. So greater the number of the collagen, greater the rate of the reaction. So high pressure, the reaction will be faster as compared to that of low pressure. So when we sketch a graph for the product, amount of the product, and time, the final product will be same, but the reaction will be different. This is B, high pressure, and A will be there for low pressure, because when the volume, the container size is smaller, the particles have more collagen. As a result, the rate or the speed of the reaction will increase. Is it clear how the pressure affects the rate or the speed of the reaction? Only for gases, because by applying a force, by applying a pressure, we can reduce the volume of gas, but solid and liquid, we cannot reduce their volume. They are not compressible, so it is not valid for solid reactants. Like if we have solid, we apply the pressure, the solid will not react faster, or if it's a liquid, we apply pressure, the liquid won't react faster. It is only for valid for gases. Then the last factor which affect the rate, that is known as a catalyst. A catalyst can also alter the rate of the reaction or speed of the reaction. So catalyst is a substance which alter the rate of reaction by lowering the activation energy. So substance which increase the rate of reaction by lowering the activation energy, we call that substance as a catalyst. And when the substance is catalyst does not take part in the reaction. The catalyst does not use up during a chemical reaction. If you use 2 gram of catalyst in the beginning, it will be 2 gram at the last. But what the catalysts do, they alter the rate of reaction, they change the rate of reaction by lowering the activation energy. What does it means? Example, we have particles. These are the particles of the reactant. Say the total energy, these particles have 30 joules. So example, we have 30 gram, we have reactants and they have 30 joules of energy. But to react, to start up the reaction, for the reaction to start, they need 100 joules of energy. So this 100 joule of energy, what we call that as activation energy. Because without this energy, they cannot react. So reactant particles have energy, but they need some more energy to reach the activation energy. So what happened? The reactant particles will not form a product or they will not react. So what is the catalyst? Catalyst is a substance. It can be a solid, liquid, gas. Normally solids are there, the catalyst, but solid or liquid are there, not gas. So catalyst is a substance or a chemical which lower the activation energy. Like example, without a catalyst, it need 100 joule of energy. But when we use a catalyst, with catalyst, it need only, like example, 20 joules of energy to react. So what happened when we use a catalyst? Because use of the catalyst lower the activation energy, lower the starting of the energy of the reaction. So when we use a catalyst, the substance will react and it will form a product. So if I say I have reactant particles, they have energy of 50 joules and the activation energy is 70 joules. Will they react? Yes or no? These are the reactant particles. They have 50 joules of energy. The reactant particles have 50 joules of energy and activation energy, starting energy. This activation energy means energy at which the reaction start. So energy at which the reaction start, that should be 70. But they have 50 joules only. Will they react? Yes or no? So there will be no reaction. Because they don't have sufficient energy, the reactants are not having sufficient energy, that's why there will be no reaction. But now the same reactant particles, same number of the particles, if you use a chemical, a substance which is called a catalyst, so they have 50 joules of energy, and with catalyst, the activation energy is 40 joules. So will they react? the reactant particles. So when we use the catalyst lower the activation energy. As the catalyst lower the activation energy, yes, they will react. So basically what catalysts do, they decrease, these are the substances which lower or decreases the activation energy so the reaction can proceed. That's why whenever we use a catalyst, the reaction is faster as compared to without a catalyst. Without a catalyst, sometimes there is no reaction or sometimes there is a very slow reaction. So when we sketch a graph for the amount of the product and time, so these are the two graphs. One is with catalyst and another one is without catalyst. Is it clear? The two graphs, that how catalyst. So basically, catalyst is a substance which reduces the activation energy, so the reactants can have more collagen, more successful collagen, which result in a faster rate. So today we have discussed the factors which are affecting the rate of reaction. The rate of reaction can be affected by temperature, it can be affected by concentration, it can be affected by surface area. Pressure is also there, it's only valid for gases. And the catalyst, a substance which speed up the reaction without chemically used up or change. Any question related to the class today? So the next session we will do um, experiments related to the catalyst and how we can identify substance as a catalyst.